Hello, this is Brett from SurvivalComms.
Man, I have a special treat for you today, especially if your radio interests are like mine and you seek unusual gear. This is a JIL SX-400 communications receiver from the late to mid-1980s. You know, these aren't typically found in the U.S. market, and I located this one at the Orlando Hamcation, the SWAT building. I picked up a number of other interesting radio items there this year, and we'll be doing videos on each one in time. You know, if you get a chance to visit the Orlando Hamcation, do yourself a favor and don't just waste your visit there in the main building with the big vendors. The real action is in the SWAT building and the tailgate area, in my opinion. I found this radio on someone's table, and it was marked as inoperative for parts only for $10. Since I had never seen one of these radios before, and physically it was complete and in good shape, I was more than pleased to pick it up for $5. I don't think he really knew what he had either. The SX-400 was actually made in Japan, and it's extremely feature-rich for its vintage. It only has a memory of 20 channels, but it covers 26 to 520 megahertz continuously. And it does AM, FM, and also wide FM. What's nice is this also features mil-air coverage, and it covers the 1 1/4 centimeter amateur band, which is unusual for a radio of this vintage. You know, oftentimes if you wanted to listen to mil-air, you ended up having to buy something like a Grove scanverter that I have in my collection. I've done a video. Here's a Grove scanverter for those of you who may not know what one of these is. Until the advent of premium quality hobbyist scanners like this Radio Shack Pro 2006, if you wanted to listen to military aircraft, you would have to rely on a device such as this, which basically went in line between a radio receiver that was capable of receiving civil aviation in the VHF range, and you would basically plug it in here and then plug in your UHF antenna here in 12 volts, and this, through images, would allow you to listen to military aircraft. Now, in order to power this receiver up, we're going to need to apply power to the power connector, and it was necessary for me to cobble one together. Now, you would think that this would just be like a standard 3-wire power plug like you would have in a Cobra 29, when in fact it's not. The pinouts are different. Your ground is to the outboard here by itself, and then you have battery positive on both the power pin that provides power to the receiver, and then also there's a memory power pin as well. Now, the receiver itself does not use a 9-volt battery to maintain memory or any kind of memory battery backup. It uses a large capacitor, and this large capacitor will maintain memories for 36 hours if you have no power applied to the device itself. And right under the power plug is the external speaker plug. Now let's talk about these other connections here. This IDE looking connector at the top is where the RC4000 factory data interface would connect, which would allow this to interface with a computer, and it provided a lot of functionality. You have the auxiliary control connection and the recorder connection here. This is what you would tie into a relay, so upon receipt of signal it would go ahead and pull the relay closed, which would trigger your cassette recorder, which the audio parts of the cassette recorder would connect right here and provide recording capability. This BNC connector here is where a factory up converter or down converter would connect to. And then you have your 2 IF outputs here, which is actually unique. And completing our tour in the back of the set, we have our data plate, our serial number plate. We have a switchable 10 dB attenuator, and then the external antenna connection, which is an SO239. Let's discuss how to operate this piece of equipment if you come across one. Once you've connected your power connector to the back of it, you have a power switch here. Turn the device on, you'll see it lights up. Now, when I first powered mine up, it didn't come on at all. The illumination for the signal strength meter came on, and I had a pop in the speaker, but everything else was dead and there was no display whatsoever. So if that's the case in a piece of equipment you come across, there's door A here, and there is a reset switch right here. And what you'll do is while the device is energized and the meaning the power switch is on and power applied to the rear connector. Execute a reset sequence by pressing in the reset switch, and your display should pop back up. While we're in this compartment, we'll discuss this. These are selectable step sizes. This is 5 and 6.25 kilohertz, and this is 12.5 and 10 kilohertz. You have a dimmer switch, you have a mute switch, and you have an antenna noise limiter for AM mode. And then this is your scan selection switch here, which basically scan will resume upon loss of modulation, carrier, or both carrier and modulation, which is kind of a nice feature for this. Over here you have your mode selection switches between AM and FM mode, and in FM mode you can select between narrow and wide FM. These are your channel selection switches, and we'll discuss how to program your channels here in a second. This is a priority switch for priority scan. You have a resume switch, so if the device stops while doing a frequency search, you just hit the resume button and it comes back in. You have a lockout button, and you have scan speed. Scan speed is either 4 or 8 channels per second. This is a stop button, and it also controls a secondary function of having a clock in here. That stands for PM, 12:18 PM. To program the clock, you can set your hour here and your minute here. Resume frequency by hitting that button again. Here's your frequency entry keypad here. If you want to set a frequency in this, like let's say we want 155 megahertz, just hit enter and bam, you're done. Let's say we want to put 146.52 in there. And enter, and we've entered in our frequency. Now if we wanted to listen to this in an AM mode, you just hit AM here, go back to FM. You can also again set it for FM wide mode or narrow mode. You have an up and a down switch here, and this is stepping through frequencies, kind of like a VFO. This particular band is set for 5 kilohertz steps. This is a scan switch for Scan A and Scan B. Scan A is all channels being scanned, and Scan B is selective scan, where you'll set individual channels that you just want to scan those, and you'll use Scan B. And we'll have to set that up. Here's your scan delay, which means upon the signal dropping, you can set the delay between 0 and 4 seconds to allow your device to start scanning again. These are your squelch attenuators for both narrow and wide, and you have your volume control here. To program channels in your scan list, just go ahead and enter a frequency, like we'll do 155 megahertz. And what we'll do is you'll just hit memory right and 1, and now that's entered into there. Let's go ahead and enter another frequency. So we'll set 460, and we want to memory right, channel 2. So now when we step through our channels, we'll see that we have those populated. Well, now that we've got our scan list populated, we can go ahead and do a Scan A. Scan A is all channels in the device. If you hit the priority button, anytime there's a transmission that takes place on channel 1 has permanent priority, and it will go ahead and stop receiving on 1 to go back to channel 1. Turn that off, you just turn it off there. Now, if you want to set individual frequencies to where you don't want to scan all the frequencies and you want to lock out certain channels, we have to set up the Scan B list. Now, in order to do that, you just have to stop the scan sequence, go ahead and hit SWM, and then hit like whatever channels you want to listen to, enter, and then Scan B. And it's only going to scan the channels that you've set that list up for. Now let's say we want to set up a seek range, like we want to check a certain range of frequencies out. What we can do is we go ahead and go into our VFO mode and set our lower limit. So we'll just set for 146 megahertz, for example. Now what we want to do is we want to set a limit entry. So we hit this right here, and let's say we just want to go over to 146.250. So it's 146.250, enter. And now we've got our limit set, and we just hit and hold down the up button, and there we go. And it's going to reset at 146.250. And again, you can set your speed here for high and low speed searching. Okay, let's do a little testing here. We're going to test the receiver's sensitivity. What we're going to do is we're going to generate a signal with my service monitor, and we've got my SINAD meter hooked up here. We're going to start with a level of 0.7 of a microvolt, that's what our signal sounds like right there. And we should get 12 dB of SINAD at a signal of 0.5 of a microvolt. So as we reduce our signal strength here, you can start to see and 12 dB of SINAD is right around there. And right now, that's at 0.2 of a microvolt of signal. So this is exceeding specifications. Now let's test our selectivity. Right now we're running at 155 megahertz, and we're running a signal right now of minus 100 decibel milliwatts. Now if I skew this thing by 15 kilohertz, it should drop by 60 dB. So let's have a gander here and see how this works out. So let's go to 155, 0, 15. I'd say we're doing pretty good. Now let's go to 155 or 154.985. And looks like we're doing good there too. The receiver is definitely more sensitive at VHF than UHF, but it's still performing within specifications in the UHF range.
Remember, Big Lou's like you. He's on meds too.
Well, I'm glad I picked this up at the Hamcation. This is an interesting radio that I'm very glad to have added to my collection. And I'm glad to have been able to share it with you guys. I hope this helps. This is Brett from SurvivalComms. Till next time.